Hello all, in this video we'll be trying to talk about k-means clustering. So we have a data set of geo. So let us have a look at that data set. So this is the data set of geo. This is nothing but a geo telephone service company, and it has different services like it provides 4G internet, 4G fiber, geo magazine, geo mart, Geo TV services, music, GeoPay, like that up to hotspot. Okay, and it has given zone-wise details here in this data set. If you just have a look at it, so there are different zones, and tenure stands for the customer's subscription date. Okay, since when the subscriber is connected with Geo, and the age of the customer, marital status of the customer. Okay, and their address is coded in numbers, and we have income which is in thousand. Okay, and the education of the customers, and rest of the data is about the services which are provided by the geo. So we have seen the data set. Now what we have to do for k-means clustering with the data set first. So I have given here geo data frame only services. Okay, we have to consider only services and remove the columns of age, region, marital status, income, and education. Let us have a look at the data set again. What we are trying to do is we don't need these details. Okay, uh, details like region, tenure, age, marital status, address, income, education. Up to education, I'm ignoring now. Why? Because I can once my objective for this k-means clustering is to cluster only the services. Okay, frequency of service usage. So based on that frequency pattern of service usage, I can later on map with these with these variables. Like once I generate cluster for these different service usage, whatever the result comes, okay, based on the cluster tag like 1 2 3, I can actually map with education, income, and address. I'll show you that. I mean, when I do it practically in R, you'll understand what I'm trying to do, right? So what I'm giving a name as geo data frame. Okay, now geo, with that data set of geo, I'm just removing the first 7 columns which I'm going to map later, not now. Now what I'm trying to do, I'm going to keep GeoDF data frame only with services data, not with customers age, marital status, or others. So I'm just removing that, and by doing this comment you can cross check. Now if you check the GeoDF data set, I'll just elaborate this, and it has consist of only the values of services. Okay, and you might ask why these values are in minus. These values are already normalized. Okay, either you can log transform or you can normalize this data. This data is already normalized to z score. Okay, now coming to the different packages which are used for k-means, I'm trying to open 4 types of packages. One is ggplot, which I'm running here, and the second one is tdverse, which is used for data manipulation, and third package is called cluster, and the fourth package is called, so the fourth package is factor extra, that is used for k-means clustering visualization. I am also opening that package as well. And now we need to identify the k value. We are doing k-means clustering, we should know what is the k value. Okay, so to identify the k value, there are two methods. One is called elbow method, and the other one is called Silhouette method to decide the number of k value. Okay, so we have already opened the related libraries, and now I am using the set seed for random selection of data, and set seed dot 123, and I'm using the function visualization of nb clust. Okay, that is, it is written, it is a function command, and inside bracket I'm trying to bring the data set of geo, which is already normalized, and it doesn't consist of any sort of string data set. So I'm bringing that geodf and comma k-means clustering. Okay, k-means method, and the method is to identify for k-means. uh, we are using the method WSS, that is nothing but your elbow method. So what this plot will tell you is how many number of clusters you can take. Okay, so let us run this command. So you will get a plot, so you have to look at the plot. So it is running and the plot is appeared, and you can press the zoom button and cross check with the data set, and you can look at here. Now how to identify the k value? As per the elbow method, it says you can actually consider the point where there is a heavy drop, and after the drop of the point, the I mean the the plot becomes flattened. Okay, so that is what is the condition given for uh, WSS method, that is elbow method. So if you look at this plot, we can see there is a huge drop here from 1 to 2 clusters. Okay, which shows we have to take number of clusters 2, and if we see the real flattening happening here after the 4th cluster. Okay, but the procedure to take 2 clusters is based on elbow method, is the point where there is a huge drop, and after the huge drop there should be a flattening of the line. So if we see here, huge drop is in this point, and the flattening is actually happening here. So we can optimally consider k value as k is equal to 3. Okay, so we are taking k is equal to 3. You can take k is equal to 2 as well, there's nothing wrong. You can take k is equal to 3. I am considering k is equal to 3 because that will give me, instead of 2 extreme clusters, if I have 3 clusters, the mid group is what will be helpful for me. So that's the purpose of creating it, k is equal to 3. Now we have one more method called Silhouette method, which is also used for identifying the k value. So same code, you just need to change the method name as Silhouette. Okay, and then I'm trying to run that, and you can zoom in the image, and it says as per the Silhouette method, it says there should be 2 clusters. But how to actually read this Silhouette plot is, it says you have to consider the number of clusters where there is a peak point. Okay, this is the peak point. As per the graph, this is the peak point. After that, there is a drop in the plot. So if you see, if you carefully look at this graph, I mean, if this plot, there is a huge rise here. I can agree that this is a peak value, but compared to this peak value and this peak value, the drop is not heavy. Wherein this and this points are, there is a drop. Okay, so that is why if you take 2 clusters, it will be an extreme, and compared to 2 or 3 clusters, third cluster is like having not much distance. Okay, so like the curve is not dropping, so we can actually take optimally 3 clusters. As per if you take 2, there will be 2 extreme clusters. If I take 3, I can get 3 clusters, one with extreme level, second with like lowest level, and third will be the mid group. Okay, so I am actually looking for the 3 groups, so we can actually take 3 clusters. So after running that, what I'm trying to do, based on I'm going for a 3 clusters. Okay, you can go for 2, you will get 2 extreme clusters, but I'm going for 3 clusters. So geo clusters, I'm giving the name, and I'm running the k-means function, and geo.df comma 3 clusters. Geo.df is nothing but your data set of data frame which you created here, and comma 3, this 3 stands for your k value, and I'm trying to run this, and you can cross check with this cluster here by running again. And now here comes the major interpretation part. Let us interpret one by one. So if you interpret the first cluster, means you have to check that there are 3 clusters, 1 2 3, these are the clusters, and these are the row wise service usage values. Okay, you have to read row wise. Yes, so you have to read these values row wise, cluster 1, cluster 2, cluster 3. Okay, for like this you have to read. Now if we read this row wise of each three clusters, which cluster is having a highest value or the lowest value? So if we see the cluster 3, okay, the cluster C, if you see the value for 4G internet voice, Geo 4G fiber, Geo magazine, Geo Mart, Geo TV, Geo Music, Geo Pay, and Geo Cinema and Geo Hotspot. If you look at these values compared to the other clusters, I mean the cluster 3 has more number of high values, okay, towards positive side. And if you look at the second cluster, which has most of the negative points, like lowest values, so you can cross check second rows. I am cross checking it. If you see, there are a lot of minus. Only the service like Geo Hotspot is somewhat positive. Rest all the values are showing it as negative. So coming to the first cluster, the first cluster you can see Geo Internet Voice, 4G Fiber, Magazine, GeoMart, GeoTV. Sorry, I just by mistakenly I said yeah, it's actually we are checking for the first row. Yeah, first row GeoMart is negative, but GeoTV, GeoMusic, GeoPay, GeoCinema, and yeah, GeoCinema. These all are showing positive values. Okay, and others are negative values. That is like this is the mid group. Okay, so we can classify this group as okay. We can classify this first group as medium group, or say medium users of geo services, the second cluster as low users of geo services, and the third cluster as the heavy users, or say large heavy users of geo services. Like that we can actually segment them. Now after segmenting them in marketing, what we do once we try to segment, that is once we try to cluster the customer database, and then we'll try to target them. Okay, so now overall it shows there are three clusters. Third cluster are known as heavy users, second clusters are the lowest users, and the first clusters are the ones who are like using few services and they are not using few other services. So now the next interpretation actually goes to cluster vector. What does this mean? This means that your first record, that is your first record, belongs to, that is first row, first row, that is first customer belongs to second cluster, second customer belongs to third cluster, third row customer belongs to first cluster. So like that there are 1,000 customers data set. This data set consists of 1,000. Like that for all 1,000, which customer belongs to which cluster is this, I mean those details are given in this clustering vector. Okay, and there are a few things which we need to check out. First thing is that cluster means, through which we could able to identify which cluster is having the highest value. Second interpretation is cluster vector, which actually tells us which customer is belonging to which cluster. So there are 1,000 data sets, and 123 stands for the cluster number, and for all 1,000 data set like customer database, who is belonging to which cluster is also shown here. And then finally what we have to do is geo clusters, that is the clustering name which we gave, and then finally we have to cross check with um, size actually tells you how many number of respondents comes under first cluster, second cluster, and third cluster. So there are 299 customers in the first, 465 customers in the second cluster, 236 customers in the third cluster. And that is what is all about the k-means clustering. Thank you.